Hello? I'm on? Okay, good. Hi, I am Jens Alfke. I'm a mobile architect at Couchbase. And this session is on what to expect in Couchbase Lite 2.0. So we're currently on version 1.3.1, and we have a couple of other updates queued up. But we're also working really hard on the first really major change to Couchbase Lite since we released it in 2014, which will be version 2.0 coming out next year. And we're dividing this talk into two parts. First, my colleague Pasin will be up to talk about the API, as we're making some really significant API improvements based on a lot of feedback that we've gotten from developers. And then I'll be back after that to talk about the implementation, which is also changing a lot, and kind of talk about some of the things that matter about that for you as users. So first, here is Pasin to talk about the API.
So hi, my name is Pasin Suriyentrakorn. So I'm an engineer at Couchbase working on Couchbase Lite. So today I would like to present the new 2.0 API design for Couchbase Lite that we have been working on. But one thing to note that, so right now the API design is currently in progress. So what you have seen today might be different later in the future, but conceptually, this is something that you could expect to see in 2.0. So the goal of the new APIs are pretty simple. So the first one, we would like to make the API easy to understand and use, and we would like to align the concept of the API across platforms. So each platform will have the same set of the API features, but the presentation of the API might be different based on what makes sense to the platform. And the API will provide both document and the data model-based API. So I would like to highlight some of the key design of the new 2.0 API. So the first one is that we will not have the revision-based API anymore. So most of the time, developers do not need to deal with the document revision. So in 2.0, there will be no API to create a new document revisions, and there will be no API to access document history as well as conflicting revisions. And in 2.0, we require conflict resolution to be done when document is saved. So this is quite different from 1.0 that sometimes that you don't need to deal with the conflict revisions. You can deal with that later, and Couchbase Lite kind of select a winning revision for you. And that is kind of convenient, but there is a side effect. Like sometimes if you forget to resolve the conflicts, you could end up with a lot of conflict revision in the database, and that impact the database performance and also impact the disk space usage. So in 2.0, we require that you need to do the conflict resolutions. But we will provide kind of a default conflict resolution for you to use, or you can decide to implement one by your own. And we will provide some of the basic conflict resolution strategies, such as selecting my revisions, selecting their revisions, or select the most recent changes with revisions. When it comes to updating the documents, in 1.0, you can do it in many ways. For example, you can use document.put properties. You can create an unsaved revisions to update the document, or you can use document.update. In 2.0, we simplify that we will have only one way to update the document. So basically, you just need to get the document, mutate the document with just a simple setter method, and then when you are done with changes, you can just call document.save. And in 1.0, when you access the document content, you need to access via document property, which is the pure dictionary. So you get the dictionary, you update it, and then you set it. But in 2.0, we introduce property type accessors that you can access each property based on the type. And another thing is that the setter method can be changeable too. But this is kind of platform specific because for the language like Objective-C, it doesn't make sense to have the changeable methods because you could end up with a bunch of nested buckets, and those do not look pretty at all. And from the example of the right-hand side, you can say that you can do the changeable. You can use the changeable setter. You get the document. You can do set, and then you can do .save at the end. You don't need to refer to the original document object at all. And this could make your source code look a little bit compact. And at the bottom part, you can say that we have the type accessor for all of the most basic type that you can use. In 2.0, we introduced subdocuments. Subdocument is a new term, but it's not a new concept. Basically, subdocuments refer to inline sub-dictionary inside your document contents. So what is the benefit of the subdocuments? Subdocuments provide two benefits. So first, it provides type accessor. So with the subdocument, you can access all of the document properties the same way by using type accessor. And another benefit is that we plan to have the chain notification, so you can subscribe to chain notifications on just a portion of the contents of your document. Blob is a new type that we introduced in 2.0 to store binary data. So in 1.0, we have the concept of attachment, but the document content and the attachments are kind of separated. If you want to access the attachment, you have to access to a revision object, and then you have to call set revision.set attachment name to set the attachment, or you call revision.attachment name to get the attachment. But in 2.0, we are not going to differentiate between binary data and the other data types like string or number. So we treat them the same. So basically, if you want to set the binary data type, you create a new blob object, and then you do document.save. The same way, when you want to get the binary data type, you do document.getBlob. Yep. So the threading model. So in 2.0, we are going to have the same threading model across platform. So we are going to follow Couchbase Lite iOS model. So basically, database and documents object cannot be shared across threads. So if you are working on another thread, you will need to get a new database object as well as new document objects. And for run loop or looper environment like iOS and Android, the document object can be live. So basically, the change from another thread can be automatically updated to the same document on the other thread. But the update will happen on the next run loop so that the change from the other thread will not interfere with your current database operations. And there is one exception that internally we are still debating about this concept. So basically, if your document is currently mutated or has some uncommitted changes, the document will be detached from getting updated. So the reason behind this is that you will not get kind of like the change from the other thread will not override your current changes, so that you can maintain your data consistencies across your database operations. So chain notifications. So in 1.0, we provide database and document chain notifications. And in 2.0, we plan to provide more fine-grained chain notifications so that you can listen to the chains on the sub-documents, or you can listen to the chain on some specific properties of the document. Model. So in 2.0, we plan to provide both the classic document-based API as well as the model-based API that you can map your document data to your specific domain knowledge or your specific domain specifications. So this is not entirely new concept because currently Couchbase Lite iOS already provides CPL model, but we are going to do this across platform. So you can expect you can expect different implementation for each platform. For example, iOS will provide dynamic model, and Android you can expect some kind of annotation model. I think this is pretty much it for today. So basically, the API is currently in progress, and currently we focus pretty much on the class-based API. And once we can finalize the class-based APIs, we can move quickly to the other parts of the API. I hope you can get some kind of feeling, or you can get the sense what we are heading to into the API. And I think I will head the presentation to Jens to cover about the core implementation, the new core implementation of Couchbase Lite.
So the kind of re-implemented core of Couchbase Lite is a new library that we're calling Couchbase Lite Core, or Lite Core for short. This will be sort of the internals of Couchbase Lite 2.0, so it won't really be a separate thing that you see, but it will be this common code base inside. We're implementing this in cross-platform C++. There are a bunch of sexy new languages that I would have preferred to use, but they're not really quite mature enough yet to be used in this kind of cross-platform code at this point. It provides a C API, which is really kind of an internal or intermediate API that I imagine most of you won't ever see, but it will be used to implement the bindings to Objective-C or Swift or Java or C#. The main reason we're doing this is to get higher performance, as well as for the cross-platform purposes, obviously. And in addition, this library is going to make possible some improvements and additions to the querying APIs. So to kind of explain how we got here, I thought it'd be good to look at the history. So with Couchbase Lite, we started off, there was this sort of version 0 that never really got released that was literally a direct port of CouchDB with the Erlang interpreter and everything. And we actually got it running, but we found that it was much too slow and large to be feasible for mobile use, at least in the devices of the time, like an iPhone 4. So we kind of went back to the drawing board, and I started writing a kind of an equivalent library with the same functionality and architecture and design, but writing it directly in native code to get better performance, better integration with the platform, and so on. And so that was kind of the beginnings of Couchbase Lite. So the kind of database layer that manages the storage on top of the underlying data store library, query engine with MapReduce, the replicator, and then on top of that, an Objective-C API with a kind of a convenient, friendly API for developers to use. Then fairly soon after that started, we kind of began porting that over to Java, or kind of taking that code, looking at its structure, architecture, algorithms, data structures, and kind of implementing those in Java. And that has been ongoing since. And then at some point after that, I think we literally started with a machine translation from Java to C#, and then took that and improved the hell out of it and fine-tuned it to get our .NET implementation. So what we have at this point, this is kind of where we are now, that we have 3 implementations of Couchbase Lite, which are entirely separate source bases for the most part. And there are all sorts of problems like you'd expect, like when we find a bug and fix it on one platform, then we have to consider, well, is that bug something that affects the other platforms as well? Like, is it part of platform-dependent code, or is it something that actually exists in the shared architecture or implementation? So then we may have to make that same bug fix across other platforms. And anytime we add new features, we have to write the same feature 3 times. We also have to make sure that the APIs are staying in sync, that the sort of actual implementation behavior stays in sync, and down to details like, how long is the timeout period in the replicator? What's the maximum number of documents we'll attempt to send at once? What exactly is the error that we do in this particular boundary condition? And so it's been a lot of work. And since we have a fairly small team, it's been very difficult for us to kind of have to just divide everything up in pieces this way. So the solution, what we're doing for 2.0 is to have almost all of the code, hopefully, be in a single shared cross-platform code base. And as I said, it's in C++. That will implement the raw database key value layer, the query engine, probably the replicator. We're still deciding about that. The replicator has a bunch of other things that it needs to do. It's obviously multi-threaded. It needs to deal with I/O and networking a lot. It needs to deal with some very platform-specific features around like service discovery and handling network availability coming and going and so on. So that may end up having to be at least partially written in per platform code. We're not sure yet. But for purposes of these slides, I'm like treating it as a nice little box like all the other ones. And then the C API, as I said, on top of that. So this way, we only have to develop this once. We obviously will need less testing of it because it's one code base instead of 3, which will help us develop more reliable code. This will give the team more time to actually work on new features, since the new features will mostly only need to be implemented once instead of 3 times, unless they're up at the platform API level. And it should give us more consistent behavior across platforms. So on top of this, then, there will be wrappers for different things, an Objective-C API for iOS, Mac OS, et cetera. We can offer, we're not certain about this, we can offer a more idiomatic Swift API instead of the one that's just directly bridged from Objective-C, which will make it cleaner and more convenient to write Swift code. The C# API, the Java API, and then also the REST API is sort of a peer of these as well in the current system, and so it also can be implemented directly on top of this underlying C API. Hmm?
So the Cordova, if you're using Cordova, would that be wrapping the C API as well?
Cordova or PhoneGap will be using the REST API. Yeah, so the question is, with Cordova or a PhoneGap app, that is an app written JavaScript in the same style as a web app, which of these APIs will it be using? I think for that case, we could offer this plugin, since we have Couchbase Lite as a plugin for Cordova. We might have a plugin that literally only has the REST API part of it on top. So it would be just Lite core plus the REST API, which would help keep the code size down. We wouldn't actually need to have any of the Objective-C or Java or whatever parts of it in there.
Okay, so when we integrate with 2.0, we already are using Cordova.
Yeah, it shouldn't make any difference to you.
Okay.
Yeah, and whether to change the REST API is an open topic. But yeah, unless we start making changes at the REST API level, this shouldn't affect what you're doing at all. So I'll talk a little bit about performance. I mean, this isn't, everyone likes performance. I'm trying not to go too much into the details. I'm really excited about it, so I could have spent like an hour talking about some of these topics, but I'll be merciful to you guys. So C++ is obviously going to be, unless you screw it up, faster than, say, Java. And even Objective-C, since there's a lot of overhead in Objective-C. So we're doing low-level optimizations, like there's obviously no garbage collection involved. There's not even reference counting except in a couple of places that aren't really in hot code paths. And we're avoiding dynamic dispatch, that is virtual methods in C++, as much as we can. So a lot of this stuff, like most of this code is just like straight procedural calls that they inline really well. The smart linkers can like inline stuff across source files and so on and generate really efficient code from this. In some of the really hot areas, and this is the difficulty, that some of this code is very, very performance sensitive, especially when we get into things like indexing, or just inserting documents. Like you have 300,000 documents you want to insert into your database. That's every cycle matters when you're doing that. So in areas we are being very careful about even how much we call malloc or how much memory we copy, because memcopy does show up as a significantly hot stack frame in a lot of benchmarks. We have this interesting new data encoding called Fleece that we developed, which is, yeah, okay, it's another JSON equivalent binary encoding, and there's, I think, about a dozen of these already. What is different about this is that the data is structured so that it doesn't require parsing or memory allocation to work with. So I've done a bunch of profiling of different, like binary JSON implementations like Bson and so on. And what happens is that the parsing goes a lot faster. But most of the overhead actually turns out to be in generating this object tree from the JSON that then the rest of your code works with. So if you parse a piece of JSON, you have suddenly allocated dictionaries, arrays, vectors, string objects, maybe number objects as well. And that is actually what's really expensive, especially if you're in a garbage collected environment, because you've now created a bunch of garbage that has to be tracked and cleaned up later. So the difference with Fleece is that you can actually use direct pointers into the data instead of having to allocate new objects. So you can load Fleece into memory. You can walk through the nested dictionaries and so on, following like a JSON path or extracting data out of it without having to allocate any memory at all. And this makes it, depending on which JSON library you're using and what you're doing, but it's on the order of like 20 times as fast as JSON for a lot of these tasks. And finally, we learned a lot about how to represent our stuff in a SQL schema since we did 1.0. And I know it is sort of weird that we end up implementing a NoSQL database on top of SQLite, but it works well, and it takes advantage of a library that's already in all the mobile platforms, and that's been very highly tuned. So a lot of the low performance that we had in 1.0 is because the schema wasn't really properly designed. It was doing too much work. So we've been able to speed things up quite a lot by doing that more efficiently. So the good thing is that we have major speedups for SQLite as well as with ForestDB, whichever of those you choose to use. And in the end, I kind of have some unofficial benchmarks that I've used for years of like, importing about 12,000 documents in from an XML file and then indexing and querying and doing grouped and reduced queries and so on. And this runs between 5 to 10 times faster than 1.0 does. And that's benchmarked against the Objective-C implementation for iOS, which is already, we know it's significantly faster than either the Java or the .NET version. So hopefully all the platforms will be able to share in this like really major speed up from 1.0. Now, take these numbers with a grain of salt, because that's the current status of the code at this moment. It's not like where it's going to be by the time it ships. Adding additional features and so on can end up taking out some of the performance. And then once you drop the adapter layer to high-level, object-oriented, virtual interpreted language, that takes away performance as well. But I think we'll still end up being several times faster than 1.0 across all platforms. So I talked about some improvements to querying. The first main one is that we've found a way that we can actually support more SQL-style query expressions instead of just MapReduce. It's not nickel. Actually implementing nickel would require taking a lot of code that's been done for the server and essentially rewriting it, both because the server version of nickel is written in Go, which is a kind of an idiosyncratic language that it's not really that happy about coexisting with other languages in your program, so it would be difficult to take that code and bind it into the rest of our code base. It only has slight support for mobile as well. And then also the implementation has been tuned for work in a database server with very high scalability, and it's also very dependent on the Couchbase secondary index server to do a lot of the work. So it's as though like you were going to take MySQL and try to like stuff it into an iPhone app. You really don't want to do that. You'd want to implement it differently. So given that, it is like conceptually similar. That will let you do these same kind of descriptive queries, like where this property is this and that property is that, and this array contains something like this. We can't really talk about the public API for it yet because it hasn't been designed, and it will be platform specific, certainly. Down at the C API level, this intermediate level in Litecore, it appears to be a sort of a parse tree, like these nodes representing different things like, predicates and or expressions and things like that. And just for simplicity, it's been encoded in JSON just to make it really easy to pass across the C API. So the public API, as I said, is going to be integrated into the platform. What we really want to do is instead of just like, making you type in SQL strings, we prefer to have something like what mobile platforms offer in terms of LINQ and .NET, or NS predicates and NS expressions and so on that are used a lot in core data on iOS and Mac. So just being able to declare what you're querying for in a higher level way that's more integrated with the language, instead of like suddenly having to drop into this kind of 1960s looking SQL syntax and plugging variables into it. So here's some examples of this kind of intermediate level JSON representation. 3 kind of similar queries. And I'll come right out and admit that this syntax has been directly inspired by Cloudnets. So they have this kind of query syntax in their server database. And just kind of as a placeholder implementation, I just kind of built something based on that. But we expect this is going to change before the time that we ship. So the first one here, the first bullet item, is going to search for documents where the type property is student. The age property is a number that's greater than 12. And the grades property is presumed to be an array that contains any value in strings D or F. In the second one, the change there is that on the second line for the age, we have this bracket 1 close bracket, which is really a 1-element JSON array containing a number, but that gets interpreted as being a placeholder. So it's similar to like putting the question mark or a dollar expression or whatever in a SQL query, saying that, go ahead and compile this query now for efficiency, but when I call it, I'm going to plug in a specific value for this. And in the third one, on the third line there, it's using this kind of higher level expression called lm_match, where instead of just listing a specific set of values that you're looking for in this grades array, you get a nested expression that gives you a predicate that you want to be true of any of those elements. So here it's saying, like, in that grades property, in the array, look for values that are less than 2.0. So you can get to some pretty powerful stuff with this. Some other stuff with queries. So iOS has long had support for full-text search and geoqueries. With SQLite, we just implemented those as a layer on top of the FTS engine and the R-tree engine that are already in SQLite. With ForestDB, we kind of implemented that ourselves, and it's not as fast, and it doesn't really have all the features and so on, so it's not really a full implementation. We're going to be able to do a better job of it for 2.0, and then since it's going to be implemented down in this shared code level, it's going to be available on all platforms finally. So your Android apps and your .NET apps are going to be able to use full-text search and geoqueries. I'll talk a little bit about the C API, even though it's not something that we really intend for you guys to use. I mean, you can, but it's really intended as this intermediate layer that's going to be the glue in between the Couchbase Lite core library and the nice object-oriented, high-level API in the language that you code in Swift or Java or C# or whatever. But there's nothing stopping people from using it, and it's something that you could use if you wanted to use this on a platform, like some kind of maybe an embedded platform where you don't want to have the overhead of dropping in a JVM into your platform just so that you can use the Java API. Or if you want to port an API to some other language like Python or something, you can do that as well. So it's a bit low level. I think it's ugly, but I kind of grit my teeth when I implement or use it, but some people really do like C. So I'll give you a little taste of what this is like. This is just a really simple snippet of code that's going and reading a document out of a database. So you'll notice the calls to the API, the functions are in bold blue there. So you'll notice that they're written in the sort of pseudo object-oriented style where the first part of the function name is the class, the quote-unquote class that it operates on, and then the second half of the name is the kind of the name of the method, and then everything takes that object as the first parameter. So we're kind of trying to be object-oriented here. So the C4DB open is to open a database. You just give it a path. You get back an error. The C4 error is just a struct that is going to contain some, like a general domain of the error and the error code. Once you've opened that, so C4 database is just this opaque reference. It's just a struct that we don't define what it is, so it's just this cookie that you use. Once you've done that, you call C4 doc get to get a document out of that database given its doc ID, and the true parameter means that that document is required to exist, so that you'll get a failure back if it doesn't, instead of getting an untitled document. And C4 document is actually not opaque, or it's only partly opaque. It's a struct that has public fields that you can access, just because that makes things more convenient. We don't have to write an accessor for every individual little bit of this. So you can get the body out of it by just getting the doc selected revisions body. And then the slice struct there is it's a simple struct that just contains a pointer and a length. So it's just pointing to a region of memory without expressing any sort of ownership of it. We use this a lot in the implementation. So you get that body, and then you can call like some function of your own just based on that pointer and that size to operate on the contents of the document. Then when you're done with it, you free the document, close the database, and then free that database reference. So it's reasonably clean for a C API. And this, if you go and look at this code later, which we can because in about one slide I'm going to show you the GitHub URL. There we have Doxygen documentation for the entire C API, so it's hopefully fairly cleanly documented. So you can try this out now. That's the GitHub repository. It's in the Couchbase organization. It's called Couchbase-Lite-Core. It just follows the same naming scheme as everything else. So currently we've got it, most of the time it runs on Mac, and then it also runs on iOS, just because they're almost the same at that level. Jim Borden has been periodically building it on Windows, so there's a Visual Studio project checked in that's kept up to date. It may not always be up to date, but we try to keep it that way. And then we've added a bunch of CMake files for just doing a general build on Linux or other platforms that CMake runs on. There are some API differences at the low levels between Linux and Mac OS, since Mac OS is more BSD-like, but we've tried to account for those. I would say this is roughly alpha quality. It's nearing feature complete, and it has a bunch of unit tests that pass. It seems reasonably solid to me, and that generally means that no, it's not solid at all, but it's halfway solid. You can kind of tiptoe across it without falling through into the basement. As I said, there are Doxygen docs of the C API, so I think if you want to actually play with the C API, that should be reasonably easy to understand. That's where we are now. We don't really have any exact dates for when this is going to ship, but it's going to be in 2017, next year sometime. And of course, we will have various betas and things like that across all the platforms. And that is the end of both of our presentations, so we have time for Q&A now.
Will there be any browser viewer for the database?
Oh, will there be any browser for the database to see? I know there is a URL lookup now. If you hit 5985 or 598584 port, you can see what documents are on CB Lite. But is there like SQLite, you have a browser, you can install a SQLite browser and copy the database and query the tables and stuff. So will there be anything in CB Lite that we will be able to view using a browser?
It's a good question. I don't know if something like that that talks to the REST API is something that we will do. We currently have an application on Mac now that can read the Couchbase Lite database files.
Okay.
You can just open the file on disk if you happen to know where it is. And it would be a really good idea to extend that to work on other platforms as well. But a web-based one would be interesting, yeah. But I can't say it's something that we've got plans for.
Okay.
But we know it can be frustrating to sort of like get visibility into what actually is in your database.
Yeah, we deal with a lot of, we actually have to go look up what is in the database at some point.
Mhm.
So we do a lot of production support that way. Like our app support team has to actually restore the SQLite database and see exactly the records
Mhm.
and sometimes fix some issues. So I was just curious if.
Yeah, the viewer app is, it's in either the Couchbase or the Couchbase Labs organization in GitHub, and it's called Couchbase Lite Viewer.
It's only on Mac though, right? iOS.
It runs on Mac, yeah, but if you can the database format is compatible across platforms, so if you can like copy it over from Windows or Unix, then you could
Okay.
look at the database there.
Okay.
Yeah, I didn't hear anything about nickel. I heard it was in the pipeline.
So I talked about that, the nickel implementation. It would be nice to implement nickel, but the implementation currently is very kind of server specific, and it's written in a language that doesn't really integrate with mobile software, and it's been tuned for working in a high capacity server. So, and also we generally feel that it's, in a mobile app, it's nicer to be able to express your queries in a higher level way than having to write a bunch of, query expressions in a different language. So like Apple's core data works that way, that you have an object-oriented API for expressing queries. And in Link and .NET, then you can like write your queries pretty much in C#. And that's what we'd like to go with.
So let me make a comment on that.
Mhm.
It's just, and he's talking, and Jens is specifically talking about the string execution of nickel server side and the implementation server side. Now, from a functional standpoint, if you look at nickel as a language specification, will be some subset of that functionally. But we don't know what the API would look like, and that's what Jens has been saying.
Yeah, so you may not be typing select from, but we'll have as much as we can of the functionality of that ability to do queries that can go down inside of arrays and nested structures and find things like that.
So just stay tuned on that. So we're working on the structured query language soon, and we'll make it available as it becomes available.
I had a question on conflicts. You said in the new API that conflicts wouldn't get resolved until you tried to save. That kind of seems too late. If you've pulled something from the server and there are conflicts, then you want to resolve those conflicts before you read the data.
So basically, the config resolution can be set at different level. For example, you can set at the database level as a default, and you can set at the replication as well. So when you pull data from the database, at that time if conflict happens, it will get resolved at that time. And when if the time that when you pull the data, if the data get conflicted, so the conflict resolution needs to be done at that time by using the conflict resolution that you set at maybe at the replicator level, or if you don't set at the replicator level, it will use the one from the database level, something like that.
So the replicator may end up calling your conflict handler function as it pulls in a document that it realizes conflicts with one that you have on your system. And so you would then, do the resolution and return the resolved version, and that's what would get saved.
So it'd be similar to how it is now in that you get a notification on the replication when there are conflicts.
You don't currently get notifications on conflicts.
Okay.
They just both exist in your database at once. You can run a query to look for conflicts.
On iOS, you get a notification of changes, and you can look at the conflicts on the changes as they come in.
Yeah, if you're
Right.
watching the
Right.
database changes, you can see if there's one that has a conflict,
Yeah,
right?
yeah,
Yeah.
and that will be possible. It sounds.
The conflict will end up getting resolved before the document makes it into your database. So you won't ever actually see the conflict.
But what if you need to control how the conflict gets resolved?
Well, your conflict handler will
Oh,
see it.
okay,
Yeah,
okay.
but your main application code running in the database won't.
Okay.
And the goal there, guys, is separation of concern and conflict resolution. That conflict resolution is resolved by conflict resolved. You want.
So the conflict resolution can be handled outside of the application, correct?
No, it would be in the
So there's, okay, so all right, that's going to be problematic.
But that's the way it works now.
Except for not all applications have to understand how to resolve all conflicts. As long as something is resolving the conflicts, you're fine. But if you have an application that's using a subset of the data and doesn't understand all the data, now you're going to have to teach every application how to understand all the data so that it can possibly resolve all conflicts.
No, you only have to deal with conflicts that you had a hand in creating. The only way that the conflict is going to get to you is if you change the document in your local database and then another revision of that document comes in that
Right.
somebody else changed.
What if the application only understands a subset of the data of the document?
Well, you're probably not changing the data that you don't understand, right?
Correct, but I could change one set of data and another application change a set of data that I don't understand and now get a conflict.
Nope,
Okay.
because you didn't change the data that it was changing.
Okay, so you won't get conflicts on sub-document level on a property. The conflict has to be on a single property now?
No, it's like on a document.
Okay, still same problem. Okay.
Yeah, we'll talk afterwards.
Okay.
Going once, going twice. Sold.